Why do ancient Roman bridges stand for thousands of years, while modern concrete bridges collapse at the first serious flood? This question is forcing scientists and engineers around the world to reconsider their views on the history of architecture and the reliability of materials. We are accustomed to considering modern technology to be the pinnacle of development, but reality often proves the opposite, as evidenced by ancient ruins. Behind dry stones and old arches lie secrets that have been deliberately or accidentally lost for many centuries. How exactly did the Romans manage to outsmart nature itself and make their creations last forever, despite climate change? Every detail of their structures was designed with enormous loads and the unpredictable behavior of water in mind. Ancient craftsmen did not have computers, but their understanding of physics allowed them to create objects of incredible strength. Today, their experience is an invaluable textbook for those who want to build for centuries. Watch the video to the end, and you will learn how ancient builders used unique compositions and shapes to make their bridges stronger against the raging currents of water. What if I told you that everything you believed about the strength of modern materials is not true? We are used to thinking that modern reinforced concrete is the benchmark for durability, but its service life rarely exceeds 100 years. The Romans, however, created a material that not only resists time, but also actively interacts with the environment. This phenomenon has prompted scientists to conduct in-depth chemical analyses of ancient structures around the world. The basis of their success was a unique concrete recipe that included volcanic ash from certain regions. This specific component had special reactive properties that are absent in modern Portland cement. When it came into contact with water, a process began that lasted for decades, constantly strengthening the internal structure. The Romans called this material pozzolana in honor of the place where it was first mined. This chemical composition reacted with seawater or moisture, creating rare minerals within the structure. The resulting crystals, such as aluminum tubermarite, filled microcracks, preventing the destruction of the entire structure from within. This is reminiscent of the process of wound healing in a living organism. Thus, Roman foundations did not rot or crumble, but turned into real artificial stone. Modern concrete deteriorates over time under the influence of the external environment and corrosion of reinforcement. Roman concrete, on the contrary, used an aggressive environment for its constant renewal. This explains why bridge supports in salt water have stood for 2 millennia without visible damage. Ancient engineers found a way to make chemistry work for architecture. In the modern world, we are only beginning to understand the complexity of these chemical processes, which were available to ancient craftsmen. They did not use steel to reinforce structures, which eliminated the problem of internal corrosion. The whole secret lay in the purity and correct selection of natural ingredients. Their concrete was homogeneous and incredibly dense in structure. The Romans also added seawater to the mixture, which contributed to the formation of unique crystalline bonds. This contradicts modern standards, where salt is considered the enemy of building materials. But it was these bonds that provided incredible resistance to erosion and mechanical wear. Time proved powerless against such technology. Each foundation block was a monolith capable of withstanding the pressure of enormous masses of water. These structures did not require external cladding to protect them from the external environment. The material itself served as the best shield against the destructive effects of the climate. This is a true triumph of ancient applied science. It is important to note that the Romans strictly monitored the process of mixing and laying the mixture. They understood that even the best recipe could be ruined by careless execution. The concrete was tamped by hand with exceptional care and patience. This approach prevented the formation of air voids inside the mass. The result was a structure that surpassed many types of natural stone in its properties. Bridges became part of the landscape, literally growing together with the riverbed. This provided them with stability that is unattainable for modern prefabricated structures. Roman concrete remains one of the greatest mysteries of the past. We would love to hear your opinion. Why do you think modern companies don't use such durable recipes today? Write about it in the comments and be sure to subscribe to the channel so you don't miss any new discoveries. Are you ready to learn the truth about why the Romans chose the arch shape, not only for its beauty? The secret to the stability of ancient bridges lies in the ideal load distribution provided by the semicircular structure. Unlike the flat beams of modern bridges, an arch transfers all pressure into lateral and vertical compression energy. This allows the structure to use its own weight to increase stability. Heavy stones are pressed together by gravity, making the structure monolithic and immovable. The central stone, called the keystone, secures the entire system and prevents it from collapsing. The greater the load from above, the tighter the elements of the arch close together. This creates an incredible reserve of strength that is difficult to overestimate. During a flood, water presses on the supports, but the weight of the bridge itself helps it stay in place. The energy of the flow is distributed along the curved lines of the arch without causing critical stresses in the material. This is radically different from how modern rectangular supports react to water pressure. Roman geometry was a natural response to the challenges of nature. The Romans precisely calculated the height and width of the spans so that the flow could pass through them without unnecessary resistance. They understood the importance of free space for debris and ice to pass through during floods. This prevented the damming effect that often destroys modern crossings. Each span was a window for the elements. Modern structures often have elements that are too long and thin, which vibrate under the pressure of water. Over time, these vibrations lead to fatigue cracks and sudden collapse. Roman arches, on the other hand, dampened any vibrations due to their massiveness and rigidity. They stood like rocks, ignoring the fury of the river current. Ancient craftsmen preferred massiveness and reliability, which allowed them to withstand the impact of heavy logs. During floods, rivers carried debris from trees and other large objects. The Roman bridge took these blows to its stone chest without any damage. Strength was built into the very essence of the architectural form. The wide supports of the arch served as a reliable anchor, holding the structure in place. They were designed so that the center of gravity was always in a safe zone. Even with partial soil erosion, the arch retained its geometry and did not collapse. It was a system with a huge reliability factor. In addition, the shape of the arch allowed bridges of great length to be built without losing stability. Each section supported the adjacent one, creating a unified and unbroken architectural ensemble. This ensured an even distribution of pressure along the entire length of the structure. The bridge functioned as a single living organism. Today, engineers often strive to save materials by making structures as light as possible. But it is precisely this lightness that becomes fatal when the river turns into a devastating torrent. The Romans were not afraid of excess weight, knowing that it was their safety. The weight of stone was their best ally. Do you think the modern pursuit of elegance at the expense of reliability is the main mistake of engineers? Share your opinion on this, because every opinion is valuable. In the next chapter, you will learn how the Romans managed to build their foundations right in the middle of raging rivers. You've probably never heard of this unique secret, because building a foundation in water is a very difficult task. Roman engineers developed an ingenious method of creating dry areas right at the bottom of deep rivers. They used special wooden barriers called cofferdams. This allowed them to work in conditions that seemed impossible for that era. They drove double rows of oak piles into the bottom, which had been pre-burned to protect them from rotting. The space between these rows was tightly filled with waterproof clay and straw. Such a wall could withstand enormous water pressure from the outside. After sealing, the water from the interior was pumped out manually. On the cleared bottom, they erected massive foundations from heavy blocks fastened with iron brackets. The Romans knew that the foundation was the heart of the bridge and that it had to be unshakable. They often drove additional piles into the ground to create the most stable platform possible. The depth of the foundation often exceeded all modern safety standards. These foundations were so wide that even the strongest currents could not wash them away. The large support area distributed the enormous weight of the stone bridge over a significant area of the bottom. This prevented uneven settlement and structural distortion in the future. Stability was the top priority for ancient builders. It is important to note that the Romans never skimped on materials when creating underwater structures. They built in a margin of safety dozens of times greater than the calculated requirements. This redundancy allowed the bridges to withstand catastrophic floods. While modern budgets force us to economize, the Romans built for eternity. Hydraulic concrete, which hardened directly underwater, was often used in the construction of foundations. This made it possible to create monolithic foundations, even in places where it was not possible to completely pump out the water. This material did not dissolve or wash away with the current. They perfected the technology of underwater concreting. Roman engineers also took into account riverbed erosion for many years to come. They protected the foundations of the supports with special stone embankments and wooden shields. This prevented sand and stones from being washed away from under the foundations themselves. Each support was protected like a real fortress. The process of building a single pier could take several years of hard work. The Romans did not rush to meet deadlines, understanding the value of a quality result. Each stone block was checked for hidden defects and cracks. The thoroughness of the work was the key to the longevity of the entire empire. The foundations of many Roman bridges are still in the same perfect condition today as they were on the day they were built. Modern divers are often amazed at the precision of the stone joints at great depths. This testifies to the incredible skill and discipline of the ancient workers. The bridge began with an invisible but indestructible foundation. Thank you for watching our video on history and engineering. Where are you watching us from, and what interests you most about Roman construction methods? Like this video if you admire the courage of the people who drained rivers by hand for their great construction projects. Don't forget to subscribe to the channel so you don't miss any new videos. What you are about to learn will change your perception of the ancient people's knowledge of water physics. Roman builders understood perfectly well how water moves and designed their bridge supports with streamlining in mind. This knowledge was not accidental or intuitive. It was born out of years of observation and practice. Each central support had a sharp nose pointing against the current. This shape was not chosen for beauty. It was a well-thought-out protection against the destructive energy of the river flow. The Romans reduced the force of the water's impact on the structure in advance. This element literally cut through the water flow, directing it away from the main structure. The water did not collide with the pier with its entire mass. It smoothly bypassed it on the sides, losing some of its energy. This solution was extremely effective. It significantly reduced the pressure on the base of the support and prevented vibrations. Constant vibrations could destroy even the strongest stone over time. The Romans understood that the frontal resistance of water was the main enemy of any structure. Therefore, they sought to reduce it as much as possible. The sharp edges of the supports minimized this risk. The flow was not delayed and did not create shock waves. The structure remained stable even in strong currents. This approach significantly increased the service life of the bridge. This shape prevented the formation of dangerous whirlpools that could wash away the soil. Whirlpools gradually wash away the foundation, making the support unstable. This process is especially dangerous because it happens imperceptibly. The Romans were well aware of this effect. Whirlpools are the main cause of support erosion in modern bridges. Many collapses occur precisely because of this phenomenon. The Romans made their icebreakers massive and streamlined. They eliminated the very possibility of dangerous eddies in advance. Water passed by them with minimal friction and turbulence. The flow remained smooth and directed. This reduced the load not only on the supports, but also on the entire bridge as a whole. Such stability was the key to durability. They also often made additional small openings above the water level in the supports. These elements seemed secondary, but played an important role. They took into account the behavior of the river in the most extreme moments. The Romans always thought about the worst-case scenario. During extreme floods, these windows allowed excess water to pass through the bridge. The flow did not hit a solid wall. The water flowed freely without creating critical pressure. It was a simple and ingenious solution. It reduced the overall load on the structure and prevented it from tipping over. Even during the most severe floods, the bridge remained stable. This wise solution allowed the bridge to breathe during natural disasters. The structure worked with nature, not against it. Modern structures often turn into dams during floods. They block the flow and hold back the water. This puts a huge load on the supports and spans. As a result, destruction becomes almost inevitable. They collect debris and take the full brunt of the elements. Trees, rocks, and debris increased the pressure. Roman bridges, on the other hand, were transparent to water even in the most difficult moments. The flow passed freely through the structure. Ancient engineers thought centuries ahead, taking into account rare natural anomalies. They did not build with normal conditions in mind. They were interested in extreme cases. That is why many bridges have survived dozens of floods. The supports were designed with a wide base that narrowed toward the top. This shape resembled a pyramid. It distributed the load as evenly as possible. This made the structure particularly stable. This provided additional stability against lateral water pressure. The lower the mass, the more difficult it was to move the support. The center of gravity of such a support was as low as possible. This was a conscious engineering decision. The bridge remained stable even during very high floods. The water could rise almost to the arches, but the supports continued to perform their function. Their shape protected them from tipping over and shifting. The Romans also used smooth cladding on the supports so that water could not catch on any unevenness. The stone was carefully processed by hand. The surface was made as smooth as possible. This required additional time and labor. This prevented the stone from being destroyed by constant friction from sand and small stones. Over time, the abrasive effect of water can erode even hard rocks. The surface was treated so that the flow would slide over it. This reduced material wear. Durability was in the small but important details. Each decision enhanced the overall quality of the structure. Nothing was left to chance. It was this approach that distinguished Roman engineering. They even took into account the angle of the river's turn relative to the bridge. The direction of the current was carefully analyzed in advance. The supports were placed strictly along the line of the current to minimize resistance. This reduced the load on the side surfaces. Any deviation could lead to excessive pressure on one side. Over time, this caused cracks and displacement. Roman precision was the key to the safety of thousands of people. A mistake could be too costly. The hydrodynamic solutions of the Romans are still considered the benchmark of engineering thought. Their principles are still studied today. Many conclusions remain relevant after 2,000 years. This is a rare example of true engineering versatility. Many modern standards for the construction of supports are directly borrowed from ancient treatises. The formulas have changed, but the logic remains the same. We are merely repeating what was discovered by the great masters of the past. Ancient science lives on in every modern project. Do you think the Romans can be considered the first experts in aerodynamics and hydrodynamics? Would you like to know how they coped with extreme weather in the harshest regions of Europe? In the next chapter, you will learn why the Roman bridge in Alcantara is still considered a wonder of the world. One of the most magnificent crossings of antiquity is the bridge in Alcantara, Spain. It was built at the beginning of the 2nd century AD by order of Emperor Trajan. This structure is still used for its intended purpose, withstanding modern traffic. Its scale and power amaze everyone who sees it in person. The height of its central arches reaches 50 meters above the water level. The builders used huge stone blocks weighing several tons. These blocks are fitted together so tightly that mortar was practically unnecessary. The massiveness of the structure ensures its incredible durability and stability. No steel reinforcement was used in the construction. All stability is maintained by the weight of the stones. Throughout its history, this bridge has survived dozens of catastrophic floods. Sometimes the water completely covered its arches, but the bridge remained unshakable. It is a true triumph of engineering genius over the forces of nature. Local residents have always considered this bridge a symbol of reliability and eternity. Modern engineers are still studying the structure to uncover the secrets of its longevity. The Alcantara Bridge has proven that correct calculations are more important than any computer technology. Its stones preserve the memory of the great civilization of its builders. Every detail of this structure serves a single purpose: to stand the test of time. The bridge connects the banks of a deep gorge, where the Tagus River often shows its violent nature. But even the most violent floods have not been able to cause serious damage to it. The stone supports stand as straight as they did 2,000 years ago. The bridge's architect, Gaius Julius Caesar, was so confident in his work that he left an inscription about it. He called this bridge a structure that would stand forever. Time has confirmed his words, turning the bridge into a monument to human will. This is a rare example of a builder's ambitions fully matching the quality of the work. The Alcantara Bridge has no unnecessary decorations. Its beauty lies in the severity of its lines. Each arch is a perfect semicircle, mathematically calibrated to the millimeter. This ensures an even distribution of the enormous loads on the foundation. The harmony of form and function has reached its peak here. Even today, this bridge is capable of carrying modern trucks. Its load capacity remains a mystery to many researchers of the past. The Romans built with such a margin of strength that seems excessive to us today. But this is precisely what has allowed the bridge to survive to this day. The gorge in which the bridge stands creates a wind tunnel effect during storms. Wind and water attack the structure with tremendous force from all sides. But the massive blocks maintain their balance, ignoring any external influences. It is a veritable fortress spanning the river. The construction of such a structure in the ancient times seems impossible to modern man. We do not have the cranes and machines of that time to understand how these stones were lifted, but the result stands before our eyes as a challenge to the modern world. Alcantara remains the pinnacle of Roman bridge building. Are you ready for the shocking truth that stone can be flexible? The Romans knew how to make their bridges flexible enough to dampen dangerous vibrations. They did not connect all parts of the structure rigidly with modern cement. This allowed individual blocks to shift slightly relative to each other. This property is extremely important during severe floods and earthquakes. Modern rigid concrete bridges often crack due to sudden pressure changes. Roman masonry acted as a complex shock absorber, distributing the energy of impacts. The entire bridge could slightly play without losing its integrity. They used a dry masonry system at certain points in the structure. This prevented the accumulation of internal stresses that lead to material failure. The friction between the massive blocks dampened the kinetic energy of the flow. It was an ingenious solution, thousands of years ahead of its time. Each stone was part of a flexible network capable of adapting to external pressure. This allowed the bridge to maintain its shape even with minor ground movements. The Romans understood that absolute rigidity was the path to fragility. Flexibility was their secret weapon against destruction. Modern engineers have only recently begun to apply similar principles in earthquake-resistant construction. The Romans, however, used this knowledge extensively in the construction of important structures. Their bridges were ready for any challenges that nature could throw at them. The stones could move, but the bridge remained standing. In addition, they used lead gaskets between some structural elements. Lead is a soft metal that absorbs shocks and vibrations well. This created an additional layer of protection against mechanical wear. Such details made the bridge practically eternal in operation. The Roman fastening system also made it easy to replace damaged blocks. The bridge did not need to be demolished entirely for local repairs. This ensured the continuity of the crossing for many generations. Maintainability was built into the very concept of the project. They understood that a river is a living and constantly changing organism. The bridge had to be able to adapt to these changes without catastrophic consequences. The stone blocks worked together to maintain the overall stability of the system. It was a triumph of collective work of materials. Interestingly, many modern restorers are afraid to touch Roman masonry. It seems so balanced that any intervention could disrupt this fragile world. The Romans created a benchmark for how hard stone can be an obedient tool. Flexibility became the key to their longevity. Guess what happened next when engineers tried to replicate these methods later? In the next chapter, you will learn why the choice of location for construction was more important than the project itself. The basic question is, how did they find the ideal spot for the bridge without modern maps? The Romans never began construction of a bridge without carefully studying the geological conditions. For them, this was the first and most important stage of the entire project. They understood that a mistake at the start would lead to problems years later. Therefore, they took the choice of location very seriously. Engineers could spend months observing the river's flow in different seasons. They came to the river in spring, summer, and fall, recording changes in water levels. They were interested in everything from the speed of the flow to the composition of the bottom sediments. These observations gave them a complete picture of the river's behavior. This allowed them to choose the safest points for the supports. They tried to understand where the flow was most stable. Where the water behaved predictably, the risk of destruction was lower. This approach significantly increased the service life of the bridge. They looked for places where the rocky foundation was closest to the surface. Sometimes this required digging test pits and depressions. Supports installed on solid rock are practically immune to subsidence over time. It is these bridges that have been best preserved to this day. If the bottom was soft, they created giant artificial platforms out of stone. These platforms served as an artificial foundation for future supports. The stone was laid in layers to distribute the load. This required enormous amounts of preparatory earthwork. The work could take years before the actual construction of the bridge began. Thousands of workers carried stones and earth by hand. Each stage was supervised by engineers. Without a solid foundation, further construction was considered pointless. Each layer of the foundation was compacted with fanatical thoroughness over weeks. The workers used simple but effective tools. They repeated the process over and over again until they achieved the desired density. Patience was considered part of professionalism. The Romans understood that even a small mistake in the foundation would lead to disaster in the future. Cracks could appear decades later. They used special measuring instruments to check the horizontality of the levels. Accuracy was their religion in civil engineering. Even a slight skew was considered unacceptable. Engineers personally checked the results of the work. Their experience told them where to reinforce the structure. This demonstrated their deep understanding of the nature of materials. The builders also took into account the width of the river's floodplain during the rainiest years in history. They gathered information from local residents. The old-timers knew how far the water could go during floods. This knowledge was actively used in the design. They deliberately extended the bridge beyond the main channel, creating spare spans. During floods, the water passed under them without destroying the banks. This prevented the erosion of the abutments, which are often a weak point. Roman caution saved hundreds of their creations from destruction. Many modern bridges use the same principle. The extra length reduces the load on the main elements. The Romans came to this conclusion long before the advent of modern science. Their solutions were born from observation and experience. Roman engineers were personally responsible for the reliability of their structures. Their names were often associated with specific projects. If a bridge collapsed due to design errors, the punishment was extremely severe. It could cost them their career or even their life. This system forced engineers to be extremely cautious. It encouraged craftsmen to use only the most proven and reliable solutions. Experiments were rarely allowed and only under safe conditions. Responsibility was the best quality control in the empire. They avoided sharp bends in the river, where erosion of the banks is most aggressive. In such places, the current washes away the soil particularly quickly. They tried to build bridges on straight sections with predictable water behavior. This minimized the risk of lateral erosion of the supports over time. The Romans carefully observed the shape of the banks. If they saw signs of collapse, the site was immediately ruled out. Nature was their main teacher and ally in construction. They preferred to obey its laws rather than argue with them. The geological surveys of the Romans often amazed modern researchers with their depth. They did not have laboratories, but they had vast practical experience. They knew how to determine the quality of the soil by the vegetation and the color of the water in the wells. These signs said a lot about the composition of the soil. This empirical knowledge was accumulated over centuries and passed on as a great secret. Apprentices learned directly from masters on construction sites. Mistakes were analyzed and remembered. The bridge was the result of the collective experience of many generations. Each stone for the foundation was selected based on its ability to resist moisture. The material was tested for strength and durability. The Romans did not use porous rocks where there was constant contact with water. They knew that such stones would quickly deteriorate. They preferred hard travertine or granite for the most critical areas. The extraction and delivery of such stones was difficult, but saving money was considered unacceptable. The choice of materials was as important as the location itself. Thus, the success of the construction was determined at the preliminary exploration stage. Most of the work was done before the first arches appeared. They tried to eliminate mistakes in advance. This made Roman bridges almost eternal. Roman bridges blended perfectly into the landscape, becoming its natural extension. They did not fight nature, but complemented it. We still use their maps and routes today, recognizing their superiority. Geology was the foundation of their engineering prowess. The location for a bridge was often chosen with the military and commercial interests of the empire in mind. Roads connected cities, legions, and markets. But the technical feasibility of the project always came first on the list of priorities. Politics could not override the laws of nature. The Romans did not build where a bridge could not stand for centuries. If conditions were too difficult, they looked for another location. They knew how to wait and plan ahead. It was a pragmatic and very wise approach to infrastructure. The massiveness of Roman bridges often seems excessive to modern architects, who are accustomed to lightness. However, it was precisely their enormous weight that was one of the main factors in saving the structures. A heavy bridge is more difficult to move or knock over by the flow of water during a storm. It was physics elevated to an absolute for the sake of safety. Modern lightweight structures have high wind resistance and can be swept away by the current. Roman supports, on the other hand, were solid masses of stone that acted as anchors. The weight of the structure pressed the foundation to the bottom, increasing friction. This made the bridge virtually immune to lateral impacts from the elements. The interior of the supports was often filled with dense concrete mixed with large stones. This created a monolithic structure of incredible density and enormous mass. This approach allowed the bridge to withstand the impact of giant trees carried by the flood. The weight was a guarantee that the bridge would not shake under pressure. For the Romans, a bridge was not just a road, but a monumental affirmation of the eternity of power. They were not afraid to spend enormous resources on creating an excessively heavy structure. The result was structures that could withstand any climatic cataclysms. Massiveness was a conscious choice in favor of long-term operation. Roman engineers used the weight of each stone to reinforce the overall rigidity of the system. The stones of the upper tiers pressed down on the lower ones, preventing gaps in the masonry. This made the structure impervious to water and small particles of soil. The weight transformed the scattered stones into a single indestructible block. This approach also protected the bridge from vibrations caused by the movement of heavy carts and troops. The massive structure dampened any vibrations in their infancy, preventing them from developing. This prevented fatigue cracks from appearing in the stone blocks over the centuries. The weight served as a natural damper for the entire system. Even today, demolishing a Roman bridge is a complex engineering task due to its mass. These structures were built so that they could not be destroyed without special effort. They stand like eternal guardians on the banks of rivers, reminding us of the power of their creators. The weight of stone became synonymous with the reliability of the ancient world. The Romans understood that in the battle with the river, the one with greater inertia would prevail. The river may be fast, but the bridge must be immovable and heavy. This confrontation of forces always ended in favor of the stone giants. Mass was their main argument in the dispute with the forces of nature. Interestingly, modern calculations confirm the correctness of this approach for turbulent rivers. Many modern dams are built on the same principles of gravitational stability. The Romans discovered this law long before the advent of theoretical mechanics. Their intuition and experience were flawless. As a result, the massiveness of Roman bridges became their main protection against time and the elements. They did not need fine-tuning and constant monitoring of cable tension. The stone simply lay in place, held by its own colossal force. It was architecture of absolute confidence in the future. The durability of Roman bridges can be explained not only by the quality of construction, but also by the system of supervision. The empire had special services that regularly inspected important road structures. Knowledge about the features of each bridge was carefully passed on from masters to their apprentices. This ensured the continuity of maintenance of the structures over the centuries. If a small crack appeared in the masonry, it was immediately repaired with a special mortar. The Romans understood that a small problem today could cause a major disaster tomorrow. Constant monitoring of the condition of the supports was an integral part of state policy. Roads and bridges were the lifeblood of the entire vast empire. The Romans realized that even the most durable structure requires attention and human respect. They did not abandon their creations to the mercy of fate after the grand opening. Regular cleaning of spans from debris and sediment was a routine but important task. This kept the bridge's capacity in perfect condition. It is surprising that many bridges have survived to this day without serious repairs. This indicates that their margin of safety allowed them to stand even during periods of neglect. But it was the Roman maintenance system that laid the foundation for this longevity. They built in such a way that repairs were simple and straightforward. Modern bridges require complex monitoring of the condition of hidden steel reinforcement. Roman structures, on the other hand, were open for inspection in every detail. Any defect was visible to the naked eye and could be quickly repaired. The simplicity of the design made operation as efficient and inexpensive as possible. The continuity of knowledge allowed unique repair technologies to be kept secret. Each province had its own construction characteristics, adapted to the local climate. But the general principles of Roman quality remained unchanged from Britain to Africa. It was a unified school of engineering skill and discipline. The empire's engineers often returned to their old projects to improve them. They analyzed the behavior of bridges after severe storms and made adjustments to new drawings. It was a process of continuous learning from their own and others' successes. Experience was the most valuable resource in the Roman construction industry. Bridges often had dedicatory inscriptions with the names of those who built or restored them. This created a personal connection between the builder and his creation for many centuries. Pride in their work compelled craftsmen to do everything perfectly the first time. Reputation was more valuable than gold for a Roman architect. Even after the fall of Rome, many barbarian kingdoms tried to maintain the bridges. They understood that they would not be able to build anything like them on their own. Roman structures continued to serve people even after the civilization that created them had disappeared. It was a victory of reason over the chaos of time. Thus, a culture of maintenance was an integral part of Roman engineering success. We often forget this today, relying on the durability of modern materials. But the Romans knew that eternity requires not only stone, but also constant human care. This is an important lesson for our entire civilization. The experience of ancient Roman builders remains relevant even in the age of digital design. Today, engineers are increasingly returning to the idea of using natural, durable components. Studying the composition of Roman concrete has already led to the creation of new environmentally friendly mixtures. We understand that the past can provide answers to the challenges of the future. The desire to maximize material savings today often leads to fragile infrastructure. Reliability should be measured not in years, but in centuries, as it was in ancient times. Roman bridges serve as a silent rebuke and at the same time, a great textbook of wisdom. They show that true value is created without vanity and greed. We are beginning to realize that nature is always stronger than any temporary technological solution. Building in harmony with the physics of water is the only way to ensure the longevity of structures. The Romans did not try to conquer the river. They learned to coexist with it in peace. Their architecture was a dialogue with the surrounding world. We have much to learn from people who built not for themselves but for distant descendants. The Roman legacy is a reminder that quality is more important than speed of execution. Every arch standing today is a monument to human patience and labor. It is a hymn to the creative force capable of overcoming millennia. Future cities can become much stronger if we adopt Roman responsibility. Using materials that do not deteriorate but grow stronger over time will change the face of our planet. We must build in such a way that our grandchildren do not have to constantly patch up holes. Durability is the highest form of respect for the Earth's resources. Roman bridges teach us that simplicity is often the highest form of complexity. There is nothing superfluous in their design. Every detail has a strict function. It is minimalism perfected for the sake of achieving an eternal result. We must strive for the same clarity in our engineering projects. Interest in ancient technologies is currently experiencing a renaissance in scientific circles. Thousands of researchers are trying to recreate Roman methods in modern laboratories. This is an acknowledgement that we have lost something very important in our pursuit of progress. But time gives us a chance to correct these mistakes and build better. Let the old stones become the foundation for our new, more perfect cities and roads. The Roman Empire has disappeared, but its bridges continue to connect shores and generations of people. This is the best proof that true craftsmanship has no expiration date. We are only students on this endless path of knowledge of the world. Every surviving bridge is a time capsule that holds the secrets of great engineers. We must preserve them not only as monuments, but also as sources of invaluable knowledge. Perhaps soon we will see new cities built according to the precepts of the ancient Romans. This will be a worthy continuation of the great building tradition. As we conclude our review, it is worth admiring once again the power of the human mind and hands. The Romans proved that it is possible to create something that will outlive kingdoms, religions, and languages. Their bridges are a victory over oblivion and destruction, given to us from the depths of centuries, built for the ages as they did. We conclude our immersion in the world of the great Roman engineers and their indestructible bridges. These structures are not just roads across rivers, but symbols of the triumph of reason over the chaos of natural elements. Behind every stone lies 1,000 years of experience and the belief that human labor can be eternal. The experience of the ancients teaches us that true reliability comes from a combination of knowledge, quality materials, and a deep respect for nature. Do you think we should return to more solid and durable construction methods today? Perhaps the secret of the Romans was that they valued time in a completely different way than we do. Share your opinion on which Roman tricks impressed you the most. Suggest topics for future videos that you would like to see on our channel in the comments. And don't forget to subscribe so you don't miss new episodes about the secrets of great civilizations.